we look at the refractive index of the material of a given prism. So generally, refractive index means it is nothing but the refractive index is one which identifies the nature of the material, of course, because as a standard phenomenon we have seen glass. Refractive index of glass is going to be 1.5 and refractive index of water is going to be 1.33. Refractive index of air is going to be 1. So likewise, it designates the denser, whether it's a denser medium or rarer medium, whether it's optically denser or optically rarer, something like you can identify the optical nature with the help of the refractive index. That is the reason it is always convenient for us to find out the refractive index of a given material. That's the reason we are finding out the refractive index with the various sources. One of the sources is by using the prism. So whatever the material is given, that you are taking in the form of a prism, and using that prism we can calculate the refractive index as follows. So here let us suppose this is the prism given to us. This is the prism given to us, and here we are to look at an equilateral prism I am considering, and using this equilateral prism we are calculating, we are finding out the refractive index of that. So here let us suppose this is the equilateral prism I have, and now this is the normal drawn to the prism, and here a ray is incident, then refracted back. So let us say this is the incident ray, this is the emergent ray, and this is also always measured with reference to the normal only. So let us say this is normal 1, this is normal 2, and of course this is the prism angle A. So here, as per, if I continue this, extend this, this is continued somewhere like this. So we can just think of, so this is the prism. So when I extend this, the picture is going to be like this. So this is the ray, how it is getting refracted. So, and this is going to be the base. Now let us say this is the incidence angle I1, this is the refracted angle at first surface. So these two are the refracted angles A, B, C, let us suppose, and this is the refraction angle 2, and emergent angle, let us say this is I2. I2 is the emergent angle. Now looking at these parameters, we need to calculate what is refractive index of this prism. So first of all, I'll just consider some, I call this as M. So considering the triangle, let us say this is P, this is P, Q, R, S. So PQRS is the path of the ray that is following. Now consider the triangle AQR. Angle A plus angle Q plus angle R. Angle A plus angle Q plus angle R must be equal to 180 degrees. Here angle A plus angle Q can be written as, since it is a normal, it will become 90 minus R1. 90 minus R1 plus angle R is going to be here 90 minus R2. That is going to be 180 degrees. Therefore, simplifying this I can get A is equal to R1 plus R2. Let us say this is equation 1. Now, looking at the second case, see here, if at all this ray is not undergoing the refraction, it would have gone in undeviated path like this. So the original emergence is this. This is the original emergence. That means it is deviated by this much. So when it is deviated by this much, then deviation angle can be written as, this deviation angle can be taken as exterior angle is equal to sum of the interior angles. Exterior angle is equal to sum of the interior angles means, so D is going to be I1 minus R1, this angle, interior angle. So D can be calculated as exterior angle is equal to sum of the interior angles. Therefore, angle D is going to be I1 minus R1 plus I2 minus R2. That comes out to be I1 plus I2 minus R1 plus R2. So this is the deviation angle. Let us say this is equation 2. If at all the incidence angle is changing, then deviation angle also changes. Initially, as I is increasing, D will decrease. If you draw the graph between I and D, ID graph nature comes out to be like this. You are taking I over here, deviation angle over here. So it will gradually decrease first and then increases. So the angle at which it takes the minimum value is called as angle of minimum deviation. So DM is called as angle of minimum deviation, and at this place, at the angle of minimum deviation, I1 will become I2 and R1 will become R2. This is the condition where I1 and I2, that is angle of incidence, angle of emergence become same, and angle of refraction at the first surface will become equal to angle of refraction at the second surface. Therefore, substituting these values in 1 and 2, substituting these values in 1 and 2, equations 1 and 2, so I will be getting A is equal to 2R, which implies R is equal to A by 2, and this angle is going to be now minimum deviation angle. Therefore, DM comes out to be 2I minus 2R, which is nothing but 2R is nothing but A. Therefore, I comes out to be A plus DM by 2. So R value and I value we have got. Now you can use Snell's law. Using Snell's law, we can get mu is equal to sin I by sin R. So I is equal to A plus D by 2, A plus D by 2, and R is equal to A by 2. So substituting the values, I will be getting mu value as sin of A plus dm by 2 divided by sin of A by 2. So this is the final expression to find out the refractive index of a given material. So this is how the derivation will occur. But as far as our curriculum is concerned, we need to remember only the formula, that is mu is equal to sin A plus D by 2. Derivation of, this is what we have done. Mu is equal to sin of A plus D by 2 by sin A by 2. This is a thing you need to remember for solving the problems. So this is what about the derivation for the refractive index of a given material using the prism.